All right, welcome back. We are Game 2014. That's Mobile Game Dev 1 in the fall 2021 semester at George Brown. And it's week 11, part 2 of our broadcast and recording. And where last we left off, we had our little game working so that we had some on-screen controls. We talked about how to use platform detection in order for us to take those screen controls away when we're working with something like WebGL build or a Windows build. And we were able to successfully do that. Now, one thing we want to check before we move on to the enemy line of sight is how does it work with a real phone? Because one of the things we always have a challenge is, yes, it works nicely with the simulator, but what about on the phone? Let's go into build settings, and I've connected a little S7. So it's going to be different than an S10. And let's see what that looks like. I've connected it on here. So there's my S7. And let's see if I can build to the S7 instead of the S10. Let's do that. So again, I'm going to do a lab 8B, but I'm going to write over the existing thing. And let's see if it actually builds towards my S7. So we're doing this build. And once the build is done, what we'll do is we'll actually project. I'll see if I can project the build online by using something called Visor. See if I can bring Visor up in prep for this one. So where are you? There's Visor. Copying it over, and does it need to be unlocked? Yeah, so it's working on my phone. Okay, so let's show you what I see. And this is Logcat right from the actual device, which is pretty cool. It tells me the resolution and all that kind of stuff. Immediately, I can tell you just by looking at it, there's a problem. And I'll show you what I see right now. Let's kind of put this together. Notice that whenever I'm touching my screen, I'm getting input. This is actual physical touches. And this is the actual phone. Let's view the device. Right, so I'm connecting to the phone. And let's try. Why is it giving me error refused? Why? Worst case, I'll use reflector if I can. Oh, maybe because I'm in flight and I'm already using it. Let's stop this piece and see if I can use Visor again. Sometimes it's because I'm already using it. It's already connected to one thing. And then it's not working. There it is. Okay, so this is what I'm actually seeing. So again, you guys tell me how this works. So I've got my device. I can move left and right, and I can jump. But take a look. What I see is my button is like really small. Like it's a little dot for me. So definitely smaller than I want to. The controls also are way too sensitive, that's for sure, from left and right perspective. So that's something we should control, because if I can spam these controls like super easy. So they need adjustment for sure. So again, and I keep missing my button. So this button right here needs to be way small, way bigger than what it is. Like maybe probably twice as big as what I'm seeing right here. Okay. So that's pretty cool. Would you like to switch? You can switch back to legacy native decoder or Visor settings. Sure. All right, so that's pretty cool. Let's stop this now, and I'll just minimize this, and I'll minimize. We'll go back to this in a bit. That's the actual phone, though, right? So we'll get back to this. And so what this tells me, what this informs me, is that this button down here, the actual joystick wasn't a bad size, but this way too small, like super, super duper small. And we couldn't tell because, on the screen, I can click my mouse onto it, no problem. But this, not good enough, right? So what we need to do is in the jump button itself, let's make it so it's twice as big. Now I've made my jump button into a prefab. So in the jump button itself, what I can do is I can change the ratio, the scale to like 1.5, 1.5. And once I change the prefab, then it'll also change everything that I'm seeing. So that's pretty good. That's much better. I think it might be a better size. And let's just try that out. So save. That's one thing we figured out by just literally using the phone compared to using another device like your simulator. So save project, and let's just build and run. Now, building and running a second time, again, is kind of like an update. So it shouldn't take as long the second time around when you're building to the same device as you would if you're building fresh. Typically, that's what happens. Let's see if I'm right. And yes, see how fast that was? Like way faster than before. Once we're building a Gradle project, that's like 90% there. And copying it over. We're deploying it. It killed my program, and there's Unity. Good, much better, much better. So how does this look? It looks like this. So again, yeah, let's reconnect because this looks like it's frozen out. Let's go back to this and do it again. Yeah, sometimes it happens. Oh yeah, we found this problem before. The reason why it's not connecting is because of this logcat. Logcat. And logcat will block it because you can't do both. There we go. So again, you can see that going back and forth, but the jump button is way better size. It looks really big on the screen here, but actually, guys, it's like way better from a kind of control perspective. But one thing that I find is that this is way too sensitive, like super sensitive compared to what I would like. So that is a problem. Okay, so sensitivity, what you want to do is put a sensitivity in there and multiply whatever value you're getting from the sensitivity itself. So that's one thing we don't have. Again, how can we program that? That's in the control mechanism that we have in the player. So scripts, player behavior. And what we're getting is the x-axis itself, the joystick horizontal is super sensitive. What we want to do is we want to have a sensitivity. Let's do that. So something like a public float, and we'll call this sensitivity. And the public sensitivity number, we're going to multiply by both horizontal and vertical, even when we have input access. So it's kind of like a reduction more than anything else that we want to do. So something like less than 1, right? Instead of super sensitive. So some, times you want to multiply. Again, it's really up to you how you feel this should be. One thing we can do is we can add these two things up. So maybe 0 plus maybe my joystick, and then multiply everything by my sensitivity. So some kind of adjustment or ratio factor, whatever you want to call it. Same thing here. So again, I want to take this whole thing and multiply it by my sensitivity. And then the sensitivity value is going to be something that's between 0 and 1. So I want to make it a range between 0.1 let's say 0, 1, and 1. Actually, yeah. So it can't be less than that. And something small. So what we want to do is in the player behavior itself, and you might find a different number that works for you, but I find a sensitivity number of way less than this. Like at least like to be like half as fast, something like that, like really, really sensitive input, right? And that number has to be like slowed down by half at least, something like that. Let's see what that does. If we do that, let's test it locally first and see how that feels before we put it up remotely. Again, this is where you can use your tools to kind of see how that feels with the, this thing, right? So left and right. Other things that we can use for the joystick. So this is okay. It's not as bad. And again, I'm using a 0.5 sensitivity. Was that air control? Yeah, 0.5. So that's pretty good. So let's put that up on line. So again, build and run. Let's build that. And let's see what happens when we do this last time. And I'm doing this because, again, I'm having an opportunity to test live with the phone. I'm using a tool called Visor in order for me to be able to test what it feels like on an actual device. I personally think that even the joystick should be made larger than what it is based on the size of my phone, the size of my screen. It's quite small, right, from what I'm seeing. Again, it's not terribly bad, but I find that it's pretty small relative to what it could be. The button now, the jump button seems to be the right size, right? And the responsiveness of the jump button is really good. It feels good, right, when I'm trying it here while we're building. So the jump button doesn't seem to be a problem. Okay, it's just the other thing. The stick controls are like really fast, like super fast. Let's see if this makes a difference now with the new Gradle build. Okay, it's redoing it and we're good. Let's just kill this one so we can see what it looks like on Visor. And we'll just stop that and relaunch. Stop that and relaunch. Come on. Sometimes you just have to do it like so. Come on. Of course not. Now it's not going to show me anything anymore. What you get for free tools, right? Free tools. Visor. There we go. Relaunching Visor seemed to work. And okay, so better, kind of, but even more. Even more. Remember, touch controls and the way they work, on the screen on an emulator, I mean, I can kind of play, but it seems to be an issue. Well, look at that. That guy's in distress. He was freaking out. Look at that when he was going up. And that's because we're repositioning the platform. That's why that platform looks funny. That's a huge jump. I shouldn't be able to make a jump like that. So yeah, definitely the controller needs just in general adjusting, right? But at least it's somewhat playable at that. Maybe we should even reduce sensitivity even more. All right, cool. I think we've tried this out and we've done some testing live. I think it's time that there we go. Let's add that one. Let's see how it's going to look with the player later on. Okay, so now we've done this part. Any questions around what I just did with the testing? So it says we need to dump the lab with our device for this lab or just with the simulator. Just the simulator is fine. And someone says, is it applying more force on the actual phone or something? No, it's not that. It's because touch, the way touch works on the phone, it could be the size of my control. Like this control here, I've noticed that when I'm on my actual device, it's a little bit small. It's almost like it needs to be, instead of 1.5 times for the controller, I recommend something even bigger. Like, you know, the for my fixed joystick, we've made it 1.5. I'm thinking 2. And I know this sounds crazy because it takes up a lot of space, but I'm telling you guys, it doesn't feel right when I'm playing it in real time, right? So again, if this requires me to adjust the position again, I start off with an iPhone XR, and I want to definitely move this around. So we're going to move this so that it's inside the safe area, at least here. And again, it's twice as big, but that means we're going to also adjust the jump button so it's aligned together. That's what I like to do. And let's check other phones too. Again, I'm not going to check all of them. This seems to be about the same. The Max and the XS. So the XR, the Max, and the Pro, right? iPhone 12 Pro Max, all of them are good, right? So they're all about the same. Now, where I put it was negative 1014. The jump button is 1070. So let's do something that makes more sense. So something like, negative 1015 seems to be a good number, maybe even more. 10. Yeah, 1010. And what about the jump button? Negative 1017. And now what about the level? Negative 288. Let's make this negative 290. That's pretty good. And we'll make this 290, negative 290 here, to make this kind of in line with this thing. Okay, so that's where I would kind of put those controls first. So that's kind of a little better. Again, these numbers are based on testing as opposed to what it felt like, what it looks like here. This looks big, but actually when you actually play it on your phone, it's small. It's much smaller on the phone, right? When it comes to what it actually looks like. So, okay, good. Excellent. So part 2 for this one, let's save this, file, save project. We've made some adjustments, but what I want to do now is I want to start thinking about AI. Okay, so, and in order for us to do this, we're going to do 2 things. One, let's switch to another layout so I can do it without obstruction. Okay, so that's the first thing. And what I want to do is I want to look at the player. Here's my player. And I want to move that player different places. So let's move that player, somewhere on the left. Actually, let's undo that change. Let's move the player spawn point. I want to move the player spawn point down here. And I want to move all the enemies away. So here's my enemies. I got 3 of them. And I want to take this one, which is, or maybe this one, enemy 1. And let's move this one closer in to where I want the enemy to be, which is about right here. And so we can test with the enemy on the same screen so that we don't have to go far. So what I want is for the enemy to have some line of sight. And I can definitely choose like an array, right? So what I drew earlier was something that looks like this. I can definitely draw, here, let's just do the new picture here, what I want. So what I want and what I can have. So what I want is, if this is the platform, kind of this long platform, and if this is an enemy, here's the enemy object, and let's say this is the player object, so here's the player, just to label these so we know what we're talking about, player and enemy. I want to make it so that the enemy doesn't just see me with a line. Typically, a line of sight is literally a line in most games. So you get a line like this, and we've talked about this in physics, where you can get a line somewhere from the enemy object, and we draw a line kind of like this, and this is our line of sight. Okay, but there's issues with this, especially in a platformer. Okay, so that's why we have a multiple ways of detecting the player, and one of them is we can use a sensing radius. So line of sight, and we can use sensing radius. We haven't done sensing radius so far, but something that looks like this. So if I can't see you, maybe I can hear you. So I can detect you this way. If you're on my platform, and if I move close enough to you, this could be the sensing radius, and I can see you. So if I can't see you, but I can hear you. Okay. And, again, this might be okay. If I move my enemy, I can just use a trigger collider. And then if you're within the trigger collider or whatever, I can stop. But I really don't know where you are. I know I've heard you, but I don't know where you are, right? And what I want to do is, what if also, as an example, this isn't the case. This is one case, right? But what if I'm not using line of sight this way, but rather, what if I have another platform? This is the case that we're talking about here, right? So I have another platform somewhere down here. Maybe a platform would be nice. Somewhere down here. Or we have another platform way up here, let's say. And if the player, and this is the thoughts that I'm having here, right? Maybe bad thoughts, but it is what it is. If the player is here, right, then obviously this enemy, the way he is right now, can't detect me. But what about if the player is over here? Can the enemy see my player? All right, so lots of ways of doing this, right? We want to do some of the same things that we did before, right? So can I draw a line between my enemy and my player? So instead of having a ray that is cast straight up, like straight like that, I could decide to make a line like so that casts between the enemy and the player. And if there's nothing obstructing, and if I see the player first, right? So I'm always drawing this ray every single time, but I'm like touching the player, like constantly touching, right? So if I do making the on-screen controls rect transform points be up against 3A, I could do that. So this, if I can draw a line, then I can see the player. That's what I can do. So I always have this line, as long as it's not interrupted by something else in between, and if I can make a direct line of sight between the enemy and the player, instead of it being fixed in a particular direction, it always looks towards the player, no matter how far it is, right? That is a way I could do it, and then the enemy can see the player. So that's number one. But sometimes, we want it so that the player, as an example, could be hidden, right? And if I'm drawing this, the only way that this would be drawing, and here's a challenge, if the enemy is facing this way, that's okay, right? So this is the enemy facing. So this is the place I'm going. But what about if the enemy is facing this way, right? Away from the player. How do I know that? Right? Because if the enemy's looking this way, so they have a look direction now. It's not like how we did it in physics, right? Where we just, or sorry, in AI, where we kind of just had a very simple way of detecting. We need to know where the enemy's looking. So if my enemy's looking this way, I can't draw a line if I'm looking away from the player. So there's going to be other calculations involved. It's like I don't want to draw a line to the player unless I'm looking towards the player. So that's another complication we'd have to have. So this would be no good, right? We couldn't do this if the enemy's looking this way. And that's fine. So the other option is wherever the enemy's looking, right, is where they're casting a ray. All right, so that's another way of doing it. And I'm not saying this is the better way or a worse way of doing it. I'm just saying, let's suppose if my player is down here, okay, and I have an enemy object like so, right? And they're there. Then the enemy itself, if it's facing in this direction, has some kind of Polygon Collider, right? Where it's kind of look almost like a cone. So from here, let's say to here and to here, something like that. So I can't really see the player because the enemy is not looking down there. However, they're okay to look up. Again, you can make this work the way you like, right? If they're at the end of the platform, they can look both. You can change the size of this thing. You can turn both things on. You can have a lot of things to turn on, right? So this idea of looking to the left or looking to the right is okay. And so when I'm over here on this side, then I can flip this thing on the other way. So what I can do is I can say, if I'm on the other way, as I'm walking to kind of this way, if I'm walking this way, then same thing goes. I can have a Polygon Collider that kind of wraps this way. This is the way the enemy can look. And it's kind of looking in a cone as opposed to, as an example, in a straight line or a direct line. Okay, so this is the way I want to do it. And there's some things with this, right, that I want to try this out. This can be more interesting. Nothing's wrong with doing it the way we said before, which is actually drawing a line between the two. And if there's anything in between, then there's no line of sight, which is kind of what we talked about before, right, in AI. Well, let's try it this way with Unity, because Unity has more powerful tools. So what I want to do is establish a new class first. Let's do this, the script that I want to make first. I want to call this script line of sight. So new script I'm going to make called line of sight. Again, you can modify this script to make it so that the line of sight script does exactly what we just said, right? Which that's the way it kind of creates that, right? So, but in this case, if I double click, what I want this script to do is a couple of things. One, I want to require a Polygon Collider. I'm going to use that idea of a Polygon Collider. So I'm going to say, hey, require component, and I want to say type of Polygon Collider 2D. Okay, so that's what's going to happen. So as soon as I attach the script onto a an object, it's going to slap on a Polygon Collider 2D for me automatically. Let's also serialize this. Okay, so both those two things are true. And then what I want to do is think about some variables. And these variables are going to be like, collision information or something like that. So we'll say header. We'll call this collision properties. Or we'll call them detection properties. Detection properties. And one of them is going to be a public collider 2D, and we're going to call this collides with. Collides with. So what is it colliding with? Right, kind of thing. Because we're going to have that collider, that Polygon Collider 2D, we're going to check that, right? We're also going to have a contact filter. So public contact filter 2D, we're going to call that contact filter. Contact filters are there for you to basically say, it's like it's similar to a layer mask, all right, where we can kind of look at it and say, we'll only care about these things, but not those things. So those are the contexts I care about, not these ones. I also need a public list of type collider 2Ds, which we're going to call this collider list. Okay. I'm also going to kind of choose the line of sight collider, right? And the line of sight collider is going to be private. So we're going to call this a Polygon Collider 2D. I'm going to call this line of sight collider. And the line of sight collider is something that we're going to get a reference to. So line of sight collider is equal to get component Polygon Collider 2D, because we've already requested that all objects that kind of attach, that this script's attached to, has a Polygon Collider 2D. So we know this is going to work. We're going to change this update to a fixed update when we do our physics casting. We're going to say that, hey, physics 2D, instead of doing a line cast or a ray cast, we're going to do something else called get contacts. Get contacts from all of our contacts that we make with our line of sight collider. Let's make that contact happen. And we're going to use a contact filter to filter things off, and we're going to store the results inside of our collider list. So again, line of sight collider is the one, which is our Polygon Collider 2D. Contact filter is like a layer mask, which tells me what I can collide with, what I care about. Collider list is a list of colliders that I'm colliding with, right? And what I want to do is I want to have another private method. We're going to make this a trigger. On trigger enter 2D, where I have a collider 2D other. And we're going to say that collides with is equal to whatever the other collider is. So that's going to be our check, if you will. Collides with is just going to be our debug information. Debug, right? Where we can say, well, if the thing that we're colliding with is the first thing, the first member of the list, as an example, then we know chances are it's the same thing. If there's something in between, if we have a contact in between, we know that there's no line of sight. And we can use the same idea if we're drawing a line and then we try and find that there's something between the two things. If there's some line between them, and we can try that next time as another form of collision detection or a line of sight. So this is the first script. And we want to attach this to the enemy behavior. So the same enemy we had before. So let's go back to our enemy. And let's just choose the enemy prefab. And what we want to do here is I want to attach this script. So I'm going to say, here's my scripts. And let's grab this line of sight script and drag it onto the prefab. It's going to automatically put on a Polygon Collider 2D, which we're going to check as a trigger. That's what we're going to do here. And so that's the trigger that we're going to put in there. Okay. So that's step one. We're going to move this up because this is part of our prefab. We can do that. We can hide these ones, the box collider 2D, and the edge collider. So this is a trigger. We're going to get back to this in a second. Let's configure our line of sight script. So the line of sight script that we have down here, we're going to say that the collides with is something that's going to be calculated. Our contact filter is important. So we're going to say use triggers, right? We want to connect with triggers, other triggers. And our layer mask is going to be a platform, a wall, or a player. But we don't have player for a layer mask. So let's add one in. So again, I'm going to go to player, add in a new layer mask. We'll call this layer mask player. We'll assign it to the player object, and we'll only this object, and we'll apply all that override stuff. Okay. Going back to the enemy, any enemy, by the way, if I go back to my enemy prefab, if I go back to the enemy prefab and I click on the enemy itself, right now we can also choose player. So we have platform, wall, and player. Those are the three things we want there. Okay. We can also choose everything if you want, but for now, those three are good. Cool. So that's our contact filter. Our colliders list is 0, and it should be starting off. And what we want is, let's change our collider. So the problem with doing this is this is a prefab. So let's double click on the enemy prefab itself, and we can define what the collider is going to look like. So this is our collider. And you can see that by default, the Polygon Collider will try and snake around the object. This is not the type of collider we want. Okay. Instead, when we click on Edit Collider, we can also look at the points of the collider and the paths. Right. So here's the element. You can see that we have 9 points, right? And we can go to the enemy. We edit the collider, and we can add kind of paths to this, move these away over here, something that looks like this. And what we can do is, once we start doing this, if I go into points and paths, we can see that we have 9. Let's move this down to something like 3. Okay. And what we have when we do 3 is we have exactly what we want. We can put this on the person's eye even if we want to, right? Now we got to be careful here because it can detect itself. So we're going to come outside of itself just a little bit, just a touch, right? We don't want to care about the other collider. So rigid body is one. Box collider, we want to be outside of this box collider and the edge collider. We don't want any kind of connection with any of those things, right? So we want to kind of move this here. So we're not colliding with these ones. We don't want to go below the ground because it'll detect its ground. So again, if you can draw a line with your eye just above the ground here, we can kind of put it right about there. And we can make it so it's pretty long. So if you want to make it so it's like way over here, we can do that. We'll do the same thing for this part. Okay, that's the collider. That's the actual, Polygon Collider that we have. The numbers, just if you want the same numbers as me, to test yours out, are these numbers here. Okay, so if you're watching the video, then they're the X and Y coordinates relative to the player or the enemy is this right here. Something like negative 1.18 for the first element, this one here. And by the way, you can always see which one this is, negative 1.18, by moving it, right? Right? And 0.063 for the Y, 0.063. Clean that up a little bit, make it easy easier instead of holding a larger number. Negative 7.5 is probably okay. Negative 7.5 and negative 7.5 with a 1.5 up here, 1.55, and a negative 0. What was that before? 0.75? Sure. Negative 0.75. That seems about right. Even this can probably be cleaned up as negative 1.2. Just to make it better. And negative or 0.06. It's not going to make a difference. There. Those are numbers that are more palatable, right? Okay, so now once we have this, we have our collider. Let's test it. So going back to our enemy, let's see what happens when our enemy marches around. Can they see the player? So let's try it. And let's make sure that this is, instead of free aspect, it's landscape. And let's take a look at the scene. And let's look at that enemy. So again, the reason why the enemy is not showing up is, let's go select the enemy. And you can see what's happening. So as it kind of skims forward, it's not touching the ground. It's barely skimming the ground. It's pretty good. And the idea is if I was to move that player, right? Now, take a look where it says here, collider list right now is 0. So there's nothing that it's colliding with. But if I go closer, right here, and if I jump up and down, we should see a collider change. The collider list should kind of include my player. Watch. So, okay. So we can see that there's my player, right? It also connects with this thing. So when it comes this way, it sees this platform as it moves this way. Look, platform layer. See? But what we want is for the player to be the first thing that it sees. So this kind of works. This thing works in the way we've programmed it to do it. Questions so far about line of sight? It's not very big. Okay, it's not very long, but we can always change this to make it longer. Right now, we're just checking to see how this would work. Okay. So they're not, the opossum isn't that smart, A, that's what we're saying. And it can't see very far, B, okay? And it can only see in this cone, okay? So that's an issue. All right, cool. So now the next part. The next part is programming the player or the enemy itself to use the line of sight. Okay, so let's do that in the, we'll do that in the enemy controller. Okay, and let's see how that works. So far, what we have is the enemy controller controls movement. But what we want to do is add some additional information, right? So we know that we have movement, but we also want to have access to the line of sight. And we'll just do a drag and drop for that one. So we'll say something like header, we'll say player detection. We can use line of sight or detection radius. For now, we'll use a public line of sight script, which we'll call the enemy line of sight. And this will be a drag and drop. We don't have to. We can detect it by using this get component line of sight on it. We can also recommend that when we slap on an enemy controller in the future, that it has an enemy line of sight, or line of sight is actually part of it. So both those two get added right away, right? So we can say something like, well, enemy line of sight is equal to get component, and we can say that that is line of sight. So we have the line of sight script. That's what that is. And if we were to run this, then enemy line of sight, if I was to click play, you're going to see that it has a reference to the line of sight script. There it is. Okay. In fact, if anything, line of sight script should kind of pre-exist before the enemy controller itself. I can see before I can move. Ideal, right? So again, to do that in the prefabs, I would go into the enemy and move the enemy line of sight script up there, just to show order of precedence, if you will. And then it'll show up the same way in all the other ones. Awesome. So we've got this enemy line of sight. That's kind of the first step. Once we've got our enemy line of sight, what we want to do is we want to make a little line of sight detection algorithm. Okay, so we have a look ahead and a bunch of other stuff. Let's make a little line of sight that happens here, and it'll be a private function that returns a Boolean, right? And we'll call this has line of sight, right? Again, you can make other names for it. But what we're basically saying here is if my enemy line of sight and the collider list, if my collider list dot count is greater than 0, this is when we want to start checking. We have a collider that our object has connected with. Okay. We want to return something here. So if that's true, if the enemy line of sight collider list count is greater than 0, all right, by default, we want to return false. We don't have a collision. We don't have line of sight, because in here, we're going to determine if we do. We're going to say that, hey, if now my enemy line of sight, and we can do this in one line, by the way, but we're doing it in 2 steps. If my enemy line of sight collides with a game object with a name of, we can also use compare tag. So we can say compare tag of player. If this is true, right? That's one case. So if our actual collider collides with the player, that's part 1, right? The other part that we want to have is we want to say that that needs to be true, right? And so that's 1. And we also want to say that the enemy line of sight dot colliders, which is the collider list, we want to look at the first element of the collider list. The game object dot compare tag is also player. Okay, so those 2 things must be true in order for us to be able to compare. So both those conditions. So the thing I'm colliding with, my Polygon Collider is colliding with the player, and the first contact that it's making is the player, not something else, right? Then, and only then, will we return true. And this is a preliminary check. We're going to make this little function better over time, because there's some flaws with this thing, right? And we're going to say is the only time we're going to move my enemy from now on is if I don't have line of sight. Okay, if I don't have line of sight, then move the enemy. If I do have line of sight, stop the enemy, right? And fire. We don't have the fire piece yet, but we just want to be able to stop the enemy when the player is detected. Okay. So that's a little piece of code there. So has line of sight. So collides with, so enemy line of sight collides with is, remember that that thing we made. Collides with is a collider 2D. That's what it is. What's the collider 2D colliding with? Well, it's some kind of game object with a tag of player. If that's true, and the first item on the list, the first set of things that the thing is colliding with is also the player, that means it's like the closest thing. Because what happens is with the collision system is it creates a list of contact points. That's what it does. The collider list is actually a list of triggers, right? That's what it is. And this list is generated by all the contact points, which is something we're getting from the line of sight code, because I'm getting contacts. Get contacts gets a list, returns a list or an array of contacts. That's what it does, right? And it stores them inside of the collider list itself. So it does. So a list of contacts. So the line of sight collider is actually the Polygon Collider 2D, and whatever it touches, as long as it meets the criteria that are inside the contact filter, it stores the thing that it's touched inside of the collider list. And we want to use the contact filter because what if there's a lot of other stuff it's hitting, but you don't care about those things. All you care about is the object that it's colliding with that you want to care about. Okay. Let's check that out. Let's check this out and see if this whole craziness works. And does it make sense? Can we make it better? All right, so run it. And let's take a look at this collider list now. So the collider list, it says, okay, so as we go back, you can see that the collider list is a platform, right? And the way it would work is if I come closer with the player, and if I jump up at the right time, then this guy should stop. Take a look, watch. Right, he's stopping, he's pausing. So if I go here, he's not going to move anymore. But if I go over him, if I jump over him, it's going to turn around and fire at me again. That's the idea. So the trigger will trigger the event where if I jump up over here, and it'll work on all of them now because they all share the same script. So if I jump down and he turns around, boom, he's going to fire at me, right? Because he's on the platform and he can see me. Obviously, we want to stop his animation from going too, right? That's one thing we want to do, right? So how does that work? And again, you can see it's not perfect. Well, in the enemy controller, right, we're going to say that if we have line of sight, right, so if this is true, then see, we've kind of made it so that the enemy controller, right, the animation controller for the enemy always runs, right? It's always in run mode, right? But if the player stops or the enemy stops, then they're going to stop animating. Okay, so we don't have access to the animator, so let's add that in. So we'll say something like, hey, here's a new header. We didn't get to this in the first section. So animation, right? And we want the animator to be here. So we're going to say public animator, right? We'll call this the animator controller. And we know that the animator exists, so we can, again, get it. We can say that, hey, let's get a reference to that. So we'll say that animation controller and then get component, sorry, is equal to get component uh, animation controller or animator. Okay, oops. And what we want to do is, if the enemy has line of sight, I want to play the animation. Otherwise, I want to stop animation from working. Okay, so Kiera says there's a bit of an issue with this implementation because if there's a block in front of the player, such as that block in the first list, then the player will remain second, even if they move in front of the block. Okay, let's see. So I'm moving, I have a block. I'm not being seen, but I move in front of the block. And then now I am being seen and it won't detect me. Is that what you're saying? Or if there's a block behind me. What do you mean by that, Kiera? I'll wait for your response, but let's do this. So I want the animator controller to stop. So if I don't have line of sight, then I want the animator to go. So animator controller dot, and you can see that I have play, and I could, kind of call out a state name, right? And let's suppose the state name is idle, right? I'll play idle, right? And let's just try this and see what it does, if it even works. Remember that the way we did the animator controller for the player is inside of sprites and the animation. We did the enemy. We have our enemy animation controller, and it has a run. That's what it has to be, run, right? So we call this run. However, if not, if I do have line of sight, then, well, for now, I want to say that the animator controller dot stop. I want to stop the animator controller from running. So that's stop playback, which stops any animation from working whatsoever. But when I go back, if I don't have line of sight anymore, it'll start running again. Let's see if this works. Player, block, enemy, can't see. That's good. Player that moves in front of the block, player, enemy, still can't see, assuming the enemy hasn't turned around in between. Yeah. So there's, again, these are tweaks we have to make sure that this, what you're saying, won't happen somehow. Okay, so let's check this out, because we've already detected the block and the player, because the opossum hasn't turned around or stopped detecting the player's moved out. Then we want to kind of get a refresh list on a regular basis. So that's something that we're going to have. That's a problem. That's definitely a problem. But that would be the same problem in another case as well, right? We move away, we draw a line, we might have that same issue. Okay, so, but anyways, this is just one way of doing it. All right, so let's try that out. So we don't see the player, the opossum should run. We do see the player, and the opossum should stop running. And it should even stop animating. Let's see how that works. So that didn't quite work, right? So we want it to stop playback, but actually it continues to play back. So what's a good way of stopping playback then? We have the animator controller. We know this is working. The run animation is working. So how do I stop playback then? Okay. What else can I do? So we have some stuff, right, that we can do, right? And a lot of times the animation controller has everything here. Stop playback, we can crossfade, and we can get integer and set integer. We've done that before. And set floats and set booleans, right? So we want to be able to stop. That's what we want. That's what we want to do, stop. Stop is deprecated, right? And it says what you want is use animator enabled is false instead, right? So let's do that. So set animator controller enabled is equal to false. And that's what it does. Let's see if that works better. But then we'd have to enable it again, yeah? I mean, I guess we could do that. Oh. Yeah, see that? Look at that. Now it's disabled. He's flying now, right? Okay. And so we can say that, okay, so the animator is enabled, is equal to true, and play the run. Let's see if this works. So he's stopped. Yeah, this controller needs to be so he stopped and then he would fire at you. Right, that's the idea. Right? Now what you said is the problem with the block. So let's say, for example, I have a block in the environment, let's say a prop. Here's my props. And let's put another prop in here. So let's go in prefabs and grab another block, put it into the scene. Right? And let's make sure, well, blocks are a problem, right? Because the block prefab itself in the sprite renderer, because of the background, won't show up because it should be on number one, on order in layer one. Here's the block here. And I want to say that what if this is true? I'll put this block somewhere here. We'll put the opossum somewhere here and make the block very heavy. So we won't make it move, this particular block itself, not all of them. And let's get that block and put it inside of props. There we go, block. And we'll make this one super heavy. So in the rigid body area, we'll make it so that the mass is 10. Okay, so heavy, won't be able to move, and chances are it won't move it. So let's try this out, and it'll stop. Now what it should do, remember that blocks are walls, and it should flip around, right? And now it's not doing it. So that's something that we can see why there's a bit of a bug there, and we can figure out what's happening. So here we can see that it is it colliding with this object? So again, we want the enemy itself, the look ahead point or look in front point itself. So enemy, look in front point. Want to push this out just a little bit more, right? This part. And so it can collide with an object that has it's named as a wall, because this is our object should say wall, right? And let's see if this one will work by modifying it, and then I'll modify all the others. Yes, just need a little bit more nudging. So if that's the truth, then this enemy here, which is this one, it's a bit of a bug, and that is this enemy. We're going to override the transform for that one, which all of them means that they'll all override, and now the blocks will work nicely. So they'll hit the block and go the other way. All right, so if that's the case, when I put a block down, I can't push it, neither can the player, and it'll just stop the thing from working. So this is your test, Kira. And we can see that we can detect the player, right? So let's take, let the enemy will see through the block. So look ahead and let's look at the enemy itself. And we'll just kind of hide this so you can see everything. There's the player being detected, but the player is, it's the first one. That's interesting. So the player comes first, not the block, right? And that's the error, right? But the block is first, not the player. So the block, it collides with the block first. It's colliding with the block, but it's not colliding with the player. That's what's happening. Okay, let's do it. And then we'll pause the game and move the player around. It's going to mess up the Cinemachine for a second, but that's okay. So we'll do, it detected the block first. So if I look at the enemy, platform layer block has been detected. And what about if I do this? Oh, damn. Hot damn. Let's try that again. Okay, so no player detection, and now it's detecting the block, but not the player. And that's exactly what you said. So block is first, but not player. Because it was already, so the player capsule, the collision's happening with the player capsule first, but the block seems to be in the way. Okay. So in the Animator Controller, you can set the speed of the animator based on float parameters. So you can use speed, float, set it based on the animator's current velocity. That's not bad. I like that. You'll probably have to pause the game, and you also don't have use layer mask bool set to true. Use layer mask bool. I don't think I need that, but you're talking about in the contact filter, because oh yeah, that is a problem. Yep, that definitely needs to be put in, or else it'll always detect everything, not the stuff that I want. Okay, so but that again, that shouldn't make a difference because right now it's just detecting everything, all triggers basically. So detecting those things, good, good, good. And then if I go here and gotta time it. There we go. That's the case right here. So I was on there and then I slipped down there, and now the block, I've got the player first, but the block is colliding with the block first. It already collided with the block, and so this kind of situation where it's set up differently is where the issue is. Okay, so again, what do you propose? What are your thoughts, guys? By the way, we should do that. We should do that for all enemies, not just for one enemy. So there's an issue. How do we fix it? I'm saying, what are your thoughts? I mean, again, sticking with what we're doing. If we don't want to use this method, that's a fix too. But I'm saying this is just one. I'm kind of selecting a way of saying, hey, I want to have this conical sight almost, right? Okay, so so Kira says, first thought is use the Polygon Collider to determine whether to check, but then use a raycast when actually checking, okay, as opposed to a list of objects that we're connecting with, kind of thing. I mean, yeah, but the idea here is we can make this this sight for the player, this idea of sight. What's the point, you might say? But if I want to do this idea of sight, like an actual sight, what if I made this way longer, right? Something like looks like this. Gotta be careful not to skim the ground too much. And we're going to make sure the numbers make more sense for the points, because these points which have to be the exact same. So negative, let's say 14 and negative 14. And let me use a longer sight this time. So bear with me while I'm doing this. So this negative 14, negative 14, 1.529, that's above. So let's say 1.5 and negative 0.6, negative 0.6, right? And what does that look like now? It's pretty good. So kind of a lean line of sight, but way far away, where it kind of starts off as a cone and it kind of creates this area here that I can look at, right? I could also make it so that I could see far above me or below me, right? And what about if I was going to go too low? Well, then I would see the ground itself. And if I see the ground, I'm actually colliding with first pretty much all the time, depending on how close the player is. So if I'm over here, but there's a ground, there's a kind of ground right here. If I put this down this way, so if I from this way going down this way, unless the player is like directly in front of him, he won't be able to see him, right? So that's something that's weird too, okay? But let's suppose it's this long. Will that make a difference to the way things go? And we can see what's happening where if I go out to here, and if I look at this enemy, let's pause while I select them and resume. So really, really far away. So what happens in this case? What happens when I do this? Is there an error here too? Somehow, depending on the timing. So here I'm not. And also something else, if I go on top of the block and I'm here, this is where this is the issue that we're getting here. So it can happen in a bunch of different ways where I collide with the player, but my collider list, this is what you are wanting to change, your collider list, your context is what you're thinking. Change this is what you're saying, right? So if the ray is connecting with my player, that could be a third check. I already have a ray. Guess which one that is? That is my, from my enemy, I have the look in front point, right? That's this piece. So if I'm looking in front point, then, and if it connects, that is a ray that I've already got. That could be a case where it would fix it because we already have points to look ahead, right? So I can say, well, if I'm already looking ahead, then I'm colliding with the player, right? Okay, so if the player is in the list, do a raycast directly from the player to the enemy. Okay, so you mean do this, but then do another raycast from the player to the enemy or the enemy to the player? It doesn't matter. Okay, from the enemy to the player. So do a raycast from the enemy to the player, and that's what I'm kind of doing with this thing. This is the kind of like this thing in front. So I won't get into this situation, right? But the raycast is quite small. So what you're saying is, let's make a longer one. Okay, let's code it. Let's do it. So we can fix it. So has line of sight. We say, okay, cool. Well, you know what? These tests have passed, right? We had this, then it's true. But what if another case? What if if the enemy, if the player is in the list? So that's the other case. So the case number one is, so this is kind of case one. Case one, player is Polygon Collider 2D, collides with player, or is triggered by the player, whatever you want to call it, and player is at the top of the list. Okay. Else if player is in the list and we have a raycast that tells me the players, that I can have a direct line of sight between the player and the first hit is the player. Okay, that's what you're saying. So we can do that too. So we say enemy line of sight, right? Dot collider list, right? And I want to find, right? I want to find an object. So this is something that I got to do. I got to find something where the player is in the list. How do I find that the player is in the list? Because that's what I want to do. I want to match the name of the player, in the list item itself. So how do I do that? So I can say contains, here's contains, can be null, a collider item, collider to item, that contains a player, right? So, and I think the way it looks is player. It's a game object player. Let's comment this out and see what it looks like, because I want to make sure that it's correct. Do it. So run. And then we'll stop after this, okay? Try and optimize this. Okay, so I don't care. Player capsule collider. So that's what the element is. So it's a collider, and it's the, who is it? So game object that contains an item. Well, I'd have to run through, I could say kind of an else, maybe an else, and then I would kind of run through all the colliders, right? That's another way of doing it. Compare tag, where I can create a comparable. That's more challenging. So it's like for each. So for each collider, if it exists and break, what did you put in? Yeah, that's what I was going to do. For each collider list. I mean, that's a kind of a linear check, but there's not a lot. So in collider list, so that would be the enemy line of sight dot collider list, right? And for every collider, oop, can I do that? Yeah, I can. For every collider in collider list, does that hide something? Never used. Okay. Then if the collider dot game object dot compare tag is equal to the player, then draw a, for that particular collider, draw a line between the game object and the enemy. If this is true, then draw a line. So you're saying in this statement, oh, I'll do your code, no problem. Physics 2D dot raycast raycast between the vector2, you're casting the transform position. Oh, I see. That's why you're doing a vector, you're converting to vector2, and the collider transform position. Start and direction. That position. If this is true, then we have a collision. Otherwise, return false. Well, let me just check this out. So raycast does origin and direction. Origin and direction is the collider transform position. Would that give me a direction though? Origin and direction. Huh. I mean, we can try it, but I'm not sure that this is the right direction, because the direction would be the collider transform position, which is the thing that we're colliding with, right? The player's collider, minus this one. That's the direction. And we want to normalize it. So we want to do something like minus the transform position, right? And what we want to do is we want to normalize it. So we want to vector3 dot normalize. So that's the direction. So if the transform position from there in that direction, if the raycast is a player, then true. Collider transform position minus transform. Yep. And all I did was You don't need to do a cast. I don't think. But anyway, let's see how this works and if it works at all. So this is the case where case two, player is, sorry, player Polygon Collider, no, enemy Polygon Collider collides with the player, and player is the top list. Player is in the collider list, and we can draw a ray to the player. Okay. Okay. Draw a line of the player. So this is kind of a combo. And they're suggesting some optimizations. What's optimizations? Are we invert? No, we don't want to do that. What about for each? This is going to turn into the link expression. No, we don't need that either. Okay, cool. So let's go back and try that out and see if that works any better. All right, and late. So players in the list. Players in the list. Look. And now player's always being detected because it's ignoring this thing. Right? That's what I'm saying. Like the problem with this is the ray shoots right through, doesn't stop, right? It's like the first hit has to be the player, right? So that's the thing. We can we're close. So physics ray cast hit returns either a Boolean or, let's not do this, right? We can say that var hit is equal to the ray cast. And if you look at this, then when you look at hit is a raycast hit 2D. And we can say that if hit dot, and you can see what that is, hit dot collider dot game object dot compare tag is, so that's the first hit, is equal to the player, then only then do we say that that's true. So return true. So physics raycast can be a Boolean, but it can also return a hit. And if it returns a hit, that's the overload, right? Then a hit is a raycast hit 2D, which you can check the collider name and whoever the collider belongs to. If it's the player again, the first hit, then we're good. Let's try that. See if it's any better. And again, we might be able to simplify and remove stuff, but again, we're just trying to optimize and make this funny ray cast detection work. And if you can make this work, you can make anything work, really. Right? So it's not detecting, but if I'm here, it's not detecting. Player. Didn't quite work. So raycast hit, var hit is this, if hit collider game object compare tag player. Okay, what is the hit? Let's debug that. So this is something we can try. We can try and put a breakpoint. We can attach to Unity. And we can say enable debugging for this session. And then when we press play, then it should come on. Good. There we go. So hit enemy Boolean. What is the hit? Hit is, got a hit, but the collider is enemy. Look, that's the collider. The collider, here's the size, is an enemy. Collider point, collider transform, the normal, the distance, and it's an enemy because, wait a minute, what? The collider, oh. Problem is it's colliding with itself. Yeah. So we got to start, the place that it's got to start has to have, we got to start the position, the start point. So this will work, but the start point has to start off not where the transform position is, but rather someplace else. Maybe we start it from what we already have, which is the look in front. Okay, because remember we have 2 points for the object. We have the enemy look ahead point, this part, and the enemy look in front point, which is this one. Look ahead point is like the ground check, right? So look in front point is what we want. We already have this piece. It'll start here, which is outside of the collider boundary, and it'll go from here on. Let's try that. So enemy, transform position, transform, no, it's going to be look ahead point. Look in front point dot position. Okay, let's see if that works. And we'll say that we want to go from the look in front point, look in front point dot position. That's the normalized vector. So it's kind of like a normal that points to where the player is, right? We're drawing a line, but we're removing it with the normalized piece. And then we're saying, okay, compare that with the player. And if it's true, good. Let's try this out. All right, and getting closer. Yes, yeah, we can do that too, but that we can do that too for sure. Yeah, we can say that doesn't collide. You know, the ray cast doesn't collide with. Okay, so not good, and A, right? And if we move, but it stopped us right there. What? Why did he stop sooner? That's weird. So it kind of, our ray is very, very small, like super small, like right in front, like we said. So if it's in front of the block, it works. But what if it should have worked over here too, right? So hit collider, it does the raycast from the look in front position. That is the origin in the direction it's going. Collider transform position. This collider, we switch through all the colliders because it's inside of that collider particularly is in the list, right? This is why we're in here at all. So that collider, transform position, collider transform position. Or do we put the collider, not the collider transform position, the collider game object dot transform dot position. Collider dot game object transform dot position. Look in front position, do there, game object, whatever the game object is, transform dot position of the game object, not the collider. I don't think that's going to make much difference. Well, it's drawing a line. The direction is okay. Direction is where I'm looking. That's why it's normalized. But I'll take the normalization away. I don't mind. But it's just, that should draw a big line. That's what the length, that would be the size of my ray. But if that's what we have to do, we'll do it. So let's try it your way. So we'll say this, and we won't normalize. Just take away this together. And let's see if that works any better. Normalizing should actually be right because it's the direction. But anyway, yeah, I could draw a line with the gizmos, but there's no point. We're so close, and we're at the end. Same. Same. Right? Whether I normalize or not, it stops right in front of me. It's weird. It's a weird glitchy poop, right? That's what it does. So it says, hey, I'm in there. Am I in there? Am I in there? And I think I know why. I think I know why. But because the shape of the Polygon Collider, this one, there's the shape of the Polygon Collider. So it's so narrow that I wonder if I took my player for a second, let's just use some logic here. So here's the guy, here's this, here's the block, here's this, and here's this dude here, and move this guy here for now, just temporarily. And then if we turn on if he's way back here, and this guy's way over here, and then that's what it's going to be. Yeah, it should collide. That should collide like way over here because of how this thing works, right? So, it's in the list. Cycling through in the list. And if I was to turn this on, it should stop right away. I need to put my player spawn point there too. Spawn points there. Let's try that again. Now it's broken because before it was working the other way around. So that's weird. Is that broken now? Because before, if I'm in front of the block, let's take the block away for a second. So block, 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 no block. Okay, and let's put my player over, oops, undo. Let's put my player spawn point. Let's put my player over here, and let's just move my player back somewhere we don't have to see it right now. So it starts right here, but this is my spawn point, and when my spawn point starts right here, there's no block, so it should stop. So what did we break? Broke something. That works as before. But if I have more than one object in there, that's where it fails. So that's where I put the block back. And if I do it again, it's going to hit the block and it's going to keep going. That's good because it doesn't see the player. But now that it's seen the block, let's go back to the enemy for a second. Block first, players in the list. I mean, it stops, but it doesn't stop close enough. It should stop right there. Enemy line of sight, collider list, block first, collides with block, but not the player. Hey, is it because the player? Okay, so no, with the layer mask. And it works, Kara? Lucas says, okay, so let's try it. So talk to me. If that line cast works better, we'll do it. So you're doing a line cast with a layer mask. And the layer mask is you're only looking for the player? Or what are you looking for? Raycast. So Herman, what are you using? Because I want to try and do something with what we have. Oh, you use the line of sight mask. What about you, Herman? What are you using? Add a distance and a layer mask to the raycast. Okay, sure, we can do that. So instead of, we need direction still or no? So this would be normalized. So vector 3 normalized was correct then, if that's true. Because that means that, yeah, so the direction is still there. And then we're going to go, what's the next thing? We need to have a contact filter. That looks to be the next thing. Contact filter or a layer mask. And do we have a layer mask? Which layer mask are you using? Contact filter layer mask. Enemy line of sight contact filter layer mask. And the size is what you're looking at right now. So the direction and the distance. So if you say a distance of 2, that's 2 units. Sure. 2.0. That should be good too, right? Should it not? 2.0 units, no layer mask. Curious. Let's say if I didn't use a layer mask, what happens? We're getting there. Sorry, I know we're over time. Nope. Okay, let's do the layer mask. So that didn't quite work. So distance of 2. Doesn't matter what we put. The distance of 5. Doesn't matter, right? And yeah, so what did you got there? What do you got there? Oh, that's good. Yeah, yours works much better than mine. Let's do this. So, and you did a layer mask of the contact filter layer mask. Is that what you did? Okay. Contact filter. Sorry, so that it is the enemy line of sight contact filter layer mask. Enemy line of sight contact filter layer mask. Let's see if that works. But hold on a second. Share the code above. Kira, put 2 for the distance for me, but you probably want a higher number. It's only 2 wide, which is I put 2. Okay, and my thing is working. Okay, hold on a second, Kira. I'll try yours as well, and then we'll stop. I want to try both. That worked. Yep. It's got to be fixed. So, okay, so that's pretty cool. That would work. So Akira suggested was something very similar. And let's see if I can share the code from the chat, because I think it's fair. So this is what Kara suggested right here. So player tag is player. I like this because then you're not checking the compare tag multiple times. That's good. If Collider compare tag player tag, then you're using a physics 2D line cast with a hit, which is very similar to a raycast. Position is where you're starting off from. Collider transform position is your destination, your direction. And then your enemy layer line of sight contact filter layer mask is the layer mask you're using. And it looks like it's working for you. Good. Awesome. If hit collider game object compare tag is, yeah, so very similar to what we've done. Very similar. Awesome. Thank you, Kira. And thank you, Herman. All right, so really good, guys. I think we did really great. Um, so for the lab, all I need is anything that we've shared here together. If we can get even the player stopping the first time, even behind the block, without the block, I think I'm good enough for this. But I think it's an opportunity for us to use this better way of doing it, which is way better because it actually is a little bit more efficient. And we'll use this one to start off with next week. All right, so that's it for today. I'm just going to put this up on GitHub. So I'll say file, save project, and we have a better collision detection or line of sight, if you will, with some weird issues. I mean, still, it's got that weird shape, but the thing is, you can make that shape whatever you want, which is kind of cool, right? Especially for a top-down game that's almost like line of sight, where you have a conical line of sight from a top-down game. From a platformer type game, it's interesting. It's kind of a field of view that we were creating, and you can project it as high or as low as you want. It can even go through um, the ground if you want to, and that means if you make it big, I mean, again, it's going to have issues, right? But if you make it big enough, and if you're at the corner, then he'll be able to see you, right? And even if you're up there, they'll be able to see you up there. So you can make it so that it's like quite large. Let's try that out. So first of all, one thing is we have our enemy. Let's make sure any kind of overrides are kind of put in there. So we'll say apply all. That's important to do. And what we also want to do is let's use our line of sight. So what if I made, here's something before we go. What if I made this line of sight much bigger? So if I went to do this now, so say he can see anywhere here and anywhere even below the ground, like this. So something that looks like this. We can use the numbers to calculate this. Again, we can fix it by just putting the numbers back, but let's look at the points. So again, 1.4 is not bad. 14, negative 14, 14, x number 1.2, and we'll say that the y is 6.5. And then this will be negative 4.85, negative 4.85. So really big, really huge. And then if I was to save it and go back out and try it out, what does it do for me? Can it give me a visibility, right? And here, no. But what if I jump? Okay, so this is where I get some weird stuff happening. I'm in the air and I'm getting a line of sight reference, right? So let's see what is this thing that it tells me. It says that if hit collider game object compare tag player. So that is a potential vulnerability, guys. So it says that. So all I did was change the size of the collider, right? So it says that object reference is of an object. Animator Controller has line of sight at number 68, right? This thing right here. So it says that the hit, and if this is false, then it's going to barrel through this. So why, oh why? Hit collider game object. And you can't compare tag. So it's basically saying I'm getting something, but I can't compare tag because I'm not getting a game object. What are you getting, hit? What are you getting? That's a bug that we could find right there. Again, not perfect, but I'm curious what the hit is going to give us. So one more thing. I'm sorry. This is a bug. Okay. Get current star cast. Unity engine raycast. It doesn't give me anything. One more time. Hit dot Collider. If I don't have a hit, right, then that's right, because I'm casting right in front, right? Or no, from here to here, right? Yeah, but wait a minute. Oh, maybe the distance isn't good enough. Why would that be null, though? What would make the hit null? How would I get to that point? Come on. There. No. Okay, so when would that happen? You're right, but why? Why would I get a hit that's null? So I'm not colliding with it because I'm outside of the collider, but I can see you here. Okay. So that, okay. All right, so I see. So I'm outside the cone, basically is what I'm at. I'm outside the cone, and that's what's causing this problem. So we can say if, here we go, let's make that little check. We'll say if hit is, if hit, and just like how you did, Kira, if hit exists and this stuff, that's why you put that check earlier. If you have a hit and this, then good, because that would give us this. And that's one thing that was missing on my end. And you had put in your stuff, and I just ignored you stupidly. Let's try that again. My bad. All right, so now we shouldn't have that issue anymore. Box collider, capsule collider. And it slows down, yes, and it would fire at me at those points. And good, and that's excellent. Good. And what about if I'm down here and the enemy's there at the top? Can they see me? Let's take away the block, right? Let's take this block away. So inside the scene, click on the block, take it away, and does it see me? Let's look at the actual object itself. Let's pause, look at the object. There we go. And then resume. So this is an issue. Again, take a look. So, right, so detection. And am I being detected? It's like barely missing me, probably. That's what's happening here. So it's there, but it's not, it's missing me, so I'd have to even go wider, right? So when I'm going, like when I'm actually free of this, it can actually see my character. So it says collides with player, and then platform layer is first. I'm not the first one in there because there's another platform that I'm colliding, which is here as well. This is the same issue. Okay. But anyways, so there's some more optimizations is all I'm saying. But right now it's pretty good with what we've got. So file, save. We have more to do. File, save project, and exit. And let's put this up on GitHub. I'll just take away the debug log because I don't care about that. And that's it for today. Let's put this up on GitHub. View changes. We'll say added own like line of sight for Animator. It's kind of what that's kind of what that is. Great flexibility though, and some really good things you can learn from that, I think, because then you're playing with the colliders, and there's some really cool things you can do with raycasts. So good stuff. And let's put this up on GitHub. Any questions or comments before we go? Can't compare tags of an object that is null. Need to make sure hit is not null. Yep, thank you. All right, so that's it for me. I'm going to stop the stream, and then I'll go to any comments that we might have on with the people that are here before we go. All right, any questions, comments?